Good day, I'm Dr. T and welcome to my dining room table. Today I'd like to talk about naming organic molecules, specifically those with functional groups. So to do this, let's just start out and name some organic molecules. I'm going to start out with something fairly straightforward. Okay, so in this case we have a heteroatom. This is going to be a halocarbon or a halocarbon because it has a halogen on it. So when we name halogens, they are going to behave very much like a branch, but instead of being, methyl, ethyl, whatever, it's going to be the name of the halogen. So this guy is 3 carbons long. This guy will be propane. And it is going to have in front of it the name of the halogen, but with the last syllable replaced with the letter O. So chloro, and then I have to tell you which carbon it's on. In this case, 1, 2, 3, 1, 2, 3, it's on the 1 carbon. Chloropropane. 1 chloropropane, I should say. Now, I will point out real quick that sometimes you don't actually have to tell you which carbon it's on because it's obvious. So let's do this again, but I'm going to put it on a slightly different molecule. Let's say it's on this one. So in this case, I know that this is ethane and that the chlorine is on there, so that would be chloro. Do I have to tell you what's on the 1 carbon? No, because where else would it be? Wherever I put it is going to be on the 1 carbon. So it must be chloroethane. Yay. Now, if I want to get fancy, then I might have to tell you. So if I had this molecule, well, that would also be chloroethane. But remember back from previously, how do I indicate that there are 2 of them? I put a di. So this would be dichloroethane. Now, do they both have to be on the same carbon? No. Therefore, I need to tell you, are they on the same carbon or are they on different carbons? And as such, this would be 1,1-dichloroethane. I don't include the numbers if it's blindingly obvious that it could only be in one spot. This will vary depending on functional groups. If you have a ketone and it's, say, on the 2nd carbon of propane, well, it can't be on the 1st or the 3rd because those would be on the end and it would be an aldehyde, not a ketone. So I wouldn't name that. By the way, I also wouldn't call that propanone, I'd call that acetone because sometimes the common name dominates. Okay, actually, why don't I draw that out real quickly? Because that leads into the next way of naming these guys. Because depending on my functional group, I don't always stick the name on the front. Sometimes I stick it on the back. This is most common with oxygens. So in this case, if I was doing full UPAC, which once again we wouldn't actually do for this molecule, I would do prop, ane, but I wouldn't put the E on there. That E is going to go away, and now we're going to get a suffix of -one for the name of a ketone. This tells me that this guy is a ketone. Now, I don't have to tell you which carbon it is because obviously it has to be one in the middle because a ketone has to be flanked by carbons on either side, otherwise it's an aldehyde. Now, as I've said earlier, normally we call this acetone because sometimes the common name just dominates. Okay, so next up, let's talk a few more of those suffixes. Let's go with a fairly common molecule. That is an alcohol, and as being an alcohol, its suffix is OL. So this is going to be prop and ol. But I do have to indicate, is it this molecule or is it this one? So they would both be propanol. This would be 1 propanol, because that's on the 1st carbon. If it's on the end, it's always the 1st carbon. 1, 2, 3, 1, 2, 3 will be the 1st carbon. 1, 2, 3, 1, 2, 3. That has to be the 2nd carbon. Yay. Now I should point out that 2-propanol is quite often sold commercially by a different name. It is called isopropanol. And this one you will occasionally see as in-propanol. Although this is very rare in general. The iso means that you're one from the end, so basically it's a fancy way of saying the 2 carbon. It's a naming system that's not really used as much anymore, but certain names have just stuck. UPAC naming is not as old as you might think it would be, and some of the older names, well, we've been using them for a long time, so why should we change? Same goes for the in. That's saying it's the normal, it's in the 1 position. Once again, not a UPAC naming. If you type that into an online homework system, there's a very good chance it'll mark it wrong. But you may very well see a bottle containing isopropanol or 2-propanol. They're literally the same thing. Okay, so yeah, that's the ending. Now, you can only have 1 suffix. If you have a question as to which one it is, there are actually hierarchy tables. It's basically the more bonds to oxygen, the more oxidized that carbon is, the more likely it's going to get the suffix role. And the more reduced it is, the less bonds to oxygen there is for that carbon, the more likely it's going to get a prefix. So alcohols can get the prefix of hydroxy instead of the suffix of OL. Whoever's in dominant gets the suffix and everybody else gets stuck with the prefix. Typically speaking, once again, like the enes and the ines, if you've got a suffix, you could also name this with the number coming in the back. This is more popular if things are getting a little bit funky. By doing this, it's clear that that 2 goes with the OL and not something else. But for simple molecules, usually you don't see this style. It's a little bit more cumbersome, and propan-2-ol is harder to say than 2-propanol. Let's just be honest. Okay, so let me grab another sheet of paper and let's go for a different set of molecules and just a couple other examples. Let me get sure I get this thing in the right spot. Okay, so let's put a few things together and let's make a big complicated molecule. Okay, so let's go for this guy. One, two, three, four, five, six, 7. And then let's go for an aldehyde over here. We will stick a double bond there and maybe an alcohol over there. And oh, let's stick a chlorine in a couple of spots because why not? Okay, so let's name this thing. When naming this, yikes. Okay, I've got a lot going on. Thankfully, no branches, so I don't have to worry about longest chain. 1, 2, 3, 4, 5, 6, 7. Okay, this is hept. Okay, this is going to have a double bond, and I am going to be putting the number in the middle because we are not dealing with this. So the number is going to go there, and then this would be En. And then the ending for an aldehyde is Al. I'm not going to have to tell you where the aldehyde is because it has to be on the end of the chain. Therefore, it's got to be in the 1 carbon. So that forces this to be 1, 2, 3, 4, 5, 6, 7. Okay, so it's hept. Actually, let's go ahead and put that. That's on the 3rd carbon. Once again, these guys are numbered 1st carbon first for the double bonds. So that would be the 3rd carbon. So that would be hept 3-enol. Okay, let's go out for this end. I'm going to have a couple of things. So the OH in its suffix form is OL, and its prefix form is hydroxy. I always get 1 letter off on hydroxy for some reason. So I am going to look at my phone, which is off screen. Okay, so OH is hydroxy if it's a prefix, it's OL if it's a suffix. The Al is going to take precedence over the OL. It's got 2 bonds to carbon between the carbon and oxygen, whereas the hydroxy only has 1, so it gets the prefix. And therefore, it's going to go first. Also, I have chloro on there, and yeah, that's about it for prefixes. So I'm going to do first one first. Now, I have 3 chlorines. So this is going to be trichloro. But I'm doing alphabetical order. I'm going to base this off of the letter of the functional group, not off of the Greek number prefix that tells me how many I have. So that means I'm going to alphabetize this as C, not T. So that means it comes first. So let's write this going backwards. No space there, that's just I left too much room. And the alcohol's in the 1, 2, 3, 4, 5, 6 position. And then I've got my trichloro. And it's in the 4, 5, 6 position. So I have 4, 5, 6 trichloro, 6 hydroxy, hept 3 enal. Yeah, trying to say that 10 times fast. Trying to say that twice. But yeah, so I've got myself my molecule. Yeah, fairly straightforward. Now, one thing to keep in mind when doing these is to keep an eye out and make sure you actually know which one the longest chain is. So let me draw an example that might be a little bit deceptive. Okay, so this guy, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Ooh, 1, 2. So this guy is going to be 1, 2, 3, 4, 5, 6. 7. So it's going to be hept, and this will have a 1, 2, 3, 4, 1, 2, 3, 4. Hey, it's in the middle. 4 ethyl heptane. This is not a 3-propyl hexane, so do beware of the location on these guys. Okay, so let's actually go from the name and going backwards. That's actually quite easy for these guys. Okay, so let's go with a nice crazy name, something like 3-methyl hex-2-ene. There should be no dash there. Hex-2-ene al. Okay, so in this case, I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so I can pick whichever way the first carbon is. I'm just going to pick the one on the left. It's the easiest one for me. So he is now being defined as carbon 1. So I know the aldehyde is going to be on carbon 1 because that's what aldehydes typically do. Next up, I know that on the second carbon, I have an alkene, so that's a double bond. And I know on the third carbon, I have a methyl group. And I'm done. I've got myself my molecule. I might want to transition this into, say, a line angle, in which case I would do something like... One, 2, 3, 4, 5, 6. And that would look like a line angle for this one. Okay, we're doing pretty good. So going backwards is actually the easiest one, going from name to structure. Structure to name is the one that's a little bit tricky because you got to figure out which way your numbers are going and make sure you parse everybody together. So with that said, have a wonderful day. I'll see you in later videos.